Okay, now I want to solve another question under equation of motion. This one will be the last one we are going to do under equation of motion. And we have so many questions on the board. We are asked to resolve this question. Now, can we solve a question like this? Look at the question. We say a body at rest is given an initial uniform acceleration of 8 meters per second squared for 30 seconds, after which the acceleration is reduced to 5 meters per second squared for the next 20 seconds. The body maintains the speed for 60 seconds, after which it is brought to rest in 20 seconds. Now, question A says that we should draw the velocity time graph of this motion using the information given above. While question B says that the graph, that after drawing this graph, use that same graph to determine the maximum speed attained during the motion. While Roman figure 2, from the graph also determine the average retardition, as the body is being brought to rest. And Roman figure 3, from that same graph, total distance traveled during the first 50 seconds. And while the last question says that we should also determine the speed during the same interval as in Roman figure 3. Now, how can we really solve this question? The first thing we have to do is to determine the graph. We have to determine the graph. Now, let us determine the graph now. Drawing the graph, we're going to be having it in this form. Now, let us sit down. Now, let us see. From the question, they say body at rest is given, meaning the body starts from here, at rest. The body starts from rest. It says, given an initial uniform acceleration. Meaning, in this case, we are given an acceleration. And they give us, and we are going to determine the velocity there. We are going to determine the velocity there. Okay, let us see now. And they say the acceleration is what? 8 meter per second square. 8 meter per second square. Now, after we say for 30 seconds, mean that here is 30 seconds. 30. Now, remember the time it takes to for this body to accelerate is what? 30 seconds. Okay. Now the next one now is that let us continue. Is after which the acceleration is reduced to 5 meters per second square. It means that it is now reduced. To 5 meters per second square. Means that at this point we also determine the velocity here. Also, we have to determine the velocity and the velocity here. Okay, let us see. What is the time? They said the time is what? It's reduced to 5 meters per second square. It means that here is 5 meters per second square. 5 meters per second square. And what is the time there? They said 20 seconds. 20 seconds. You mean that 20 seconds, that is the time. Now, let us determine what will be here. Mean if here is 30 plus the 20, I'll be having here as 50. That point there will be 50. Okay, let us see the next thing now. It's after which they say the body maintains the speed for 60 seconds. When we say the body maintains, meaning is having a uniform speed. Maintain a uniform speed. That is what they are saying there. Maintain a uniform speed. Okay, for how many seconds? They said it's 60 seconds. It means that maintain it for 60 seconds. Okay, now, let us see the time I could take there. The time means 60 plus this, I'll be having 110 here, 110. Okay, let us see the next thing now. Say after which it is being brought to rest in 20 seconds. Meaning that this body now come to rest in 20 seconds. This one will be what? T second. While this one here, I'm going to be having V, which is meter per second, because that is the velocity there. Now, what is now we have done, this one is saying 20 seconds. 20 plus this, I'll be having 130 here. Meaning at this point here, it will be 130 at that point. 130 here, 130. Okay, 130. Meaning I told you last time that this one is T seconds. Okay, let us see now. The next day now, I think we are done with that. Okay, let us determine the velocity and the velocity here. To determine the velocity there, what can we do? We need to now use the formula which is equals U plus AT. Now from there, what is the acceleration? The initial, because the body start from rest. The body start from rest go to 0. What is our initial acceleration? Is sorry, our acceleration, our acceleration is what? 8. 8 times, what is the time it takes? 30. 30, okay. Here is 0, okay. 8 times 8 times 30, it will be what? 240. 240, mean that the time, the velocity there is going to be what? 240. Meaning at this point, I'll be having 240. Here is going to be what? 240 meter per second. Now, write the next one now, and after we should let us also determine this one now. To determine this very one, it is quite simple. To determine this very one, I will also use the same formula, the same formula. It means that the body is not here now. This one is going to be my initial, which is u. This one will now be my initial, which is u. And the acceleration is what? 5. 5 towards the time it takes, that is 20. Therefore, now when I times this, I'm going to be having 100. 100 plus this, I'll be having what? 340. Meaning here is 340. 340 meter per second. Okay, that is just the velocity there, and this one is another velocity there. Now, at this point now, don't forget this one is uniform. Here is uniform speed. This is where we have our uniform speed or uniform velocity. Uniform speed or velocity. At this point, the acceleration is equal to 0, is equal to 0. Please don't forget, the acceleration there is 0. Now, this is the answer to question 8. They say we should draw the velocity time graph of the motion using the information given now. But we are just determining this one is just question A. This question here, this one we have just done as question A. Now we just give time, just like 1 second to go through it while I clean the board. I'm going to clean this board so that I can have a space to solve every other question because we are having question B to solve. They ask us to solve question B to determine maximum speed attained during the motion and also average retardation and total distance traveled during the first 50 seconds and also the average speed during the same interval as in Roman figure 3. Now, please don't forget I told you before, this one is likely why question, exam question. Okay, now I'll just give you like 1 second to go through while I clean the other side of the board so that I can complete my solution. Okay, now let us now complete the solution. We have solved question A. Now we're at question B. Using the graph, we are going to determine the maximum speed attained. Now question A there's other B now. B Roman figure 1. One will determine B Roman figure 1. It says maximum speed attained. Therefore, the maximum speed attained there, maximum speed attained, maximum speed attained is this very one here. The maximum speed attained is simply this one. It means that I'm going to be having, what's the answer there? It means that I'm going to be having my speed, maximum speed, which is now equal 340. It's going to be 340, that is the maximum speed attained during the motion. That is the maximum speed. I'm going to be having what 340 meters per second. That is what I have as my maximum speed. Either I represent it like this or I use this one to represent the unit. Remember I told you speed and velocity have the same unit of measurement. I can either represent it like this or represent it like this. This and this they are very much like okay. Now let us now see the next one now. That is Roman figure 1. Now let us now Roman figure 2. Roman figure 2. They say we should do what? I think they ask us something, the average retardation. Now to determine the average retardation, I have to come to this point where the body is coming to rest. Because that is where we can have, or that is where we can ascertain the retardation. Remember I told you yesterday when the body is coming down here, it's going to be negative acceleration. That at this point here, negative what? Acceleration. Now let us determine it. To determine it, remember I gave a formula before that is V minus U all over T. Now to do this, now what's going to be the final velocity? It's coming to red, that is final. The initial is going to be 340. At this point, I'm going to be having 340. Sorry? Yeah, okay, no. 0 minus 340 all over what the time it takes to come down, that is 20 seconds. 20 seconds. When I do that, I'm going to be having 340 all over 20. That is what we have there. 0 can kill 0. we'll be having minus, in our acceleration, will be 34 over 2, and which is minus 17 meter per second squared. That is going to be the average retardation of this body. This one is going to be the average retardation, but we can do away with the minus, and at the end, when I do away with the minus, this minus here always indicate that the body is decelerating, that the body is retarding. That is the meaning of this negative sign. But if I want to pick the value, I can say my A is equal to 17 meter per second squared. This one will be my answer to this. Okay, now let's see the next one now. The next one, they say we should calculate the total distance. That is the next one now, total distance traveled during the first 50 seconds. Remember I taught you how to determine distance. This one will be x1, this one will be x2, this one will be x3, and this one will be what? S4. Okay, let's now look at the total distance traveled. Let's now look at the total distance traveled there. Let's look at the total distance traveled from here, from the graph, and I'm going to determine that. Okay, Roman figure 3. Roman figure 3, the total distance traveled, I'm going to use the second equation of motion. Remember, I've given this formula before. That is half at squared. I'm going to be using this formula. Now, to determine x1, okay, from the graph there, the x1, because the body starts from here, I'm going to determine here this x1, this first one. I'm going to be having the initial 0, and I'll be having my time times 20 plus half times A, what the acceleration is. And what is the time? The time is 20, is going to be 20 squared. Okay, now when I do here now, this one is 0 already. Here it will be 4, because 2 here 1, 2 years, this one is going to be 4. At this point, here I'll be having 4. This one is 400. This one is going to be 400 because 20 times 20, when you put that, it's going to be 400. 0, 0. This one will be 0. And at the end, you are going to be having this time this. We are okay, 0. This time this will be what? 4. And we'll be having 400. 400 there. Meaning 20 squared is 400. Meaning that 400 now times, okay, yes, you are very much okay. That's 400 now. You mean that 400 times 4, I'll be having 1,600. I think that will be my answer there. Yeah, I'm going to be having 1,600. Yes, I'm going to be having 1,600 there. Because 4, that is 0. 4 times 0 is 0. 4 times 0 is 1, 0. 4 times this will be 16. I'm going to be having 1,600 meters at this point here. That is what I have there for my distance there. Okay, I can determine the x. Let me determine the x. Let me determine the x2. We determine the x2 there. Let us see what will happen. The x2 there meaning here. The x2 there meaning this point here. It means that to determine there, I'm going to have. Okay, I'm going to be having. Okay, now since I'm using here now, this one will become my initial. I'll be having my initial as 240. 240 plus. What is going to be the time? The time it takes to reach there is what is the time? 20. Okay, times 20 there. Okay, that is plus. Okay, half. I'm going to be having half there. Half. What is going to be the acceleration? The acceleration is 5. The acceleration there is 5. Okay. Now, what is going to be the time? The time it takes to reach there is going to be 20 squared. 20 squared. 20 squared is the time there. Okay. Now, to do that, let us see what will happen. Let us see what will happen here now. What will here give us? What is that point there going to give us? Let us see what it will give us. At that point, let us see what it will give us. Okay, yes. I think we are, let us just go through. I think we are okay with this. Remember, we are not calculating S2. We have to calculate S2. We have to calculate S2. I hope this one is okay. Okay. Okay, now we have calculated S1. We say S1 is this. The acceleration is 8. And, okay, please, we are using 27 instead of 30. This here is 30. Change it to 30. That condense here is 30. You know everything here is 0. If here is 30, here will be 900. Okay, 900 now. 900. 2 here is 0. Okay, 4 times 900 is going to be what? 4 times 900, I will be having, that is 4 times 900, and we'll be having 36, that is 3,600. Is this point here is 3,600 is correct, that please? Okay, doing this one now, what is going here is going to give us. When I multiply here, I'm going to be having 4 multiply here. Remember the way we multiply, that is 240 times 20. 2 here is 0, 0. This one will be 0. This one will be what? 2. Okay, so this one will be 0. This one will be 8. And this one will be what? 4. Therefore, I will be having 4,800 when I multiply here. And the other one there, remember here is 400. 400. If 2 enter 400, I will be having 200. 400 times 5, there will be 1,000. 1,000 there. Now, this point now I cannot add. I can add these two things here. We have 5,800 meter. That is what I'm going to be having there. Okay, now we have to be able to determine x1. X1 is 3,600 meter. We have determined x2 5,800 meter. Now look at the same should calculate the total distance travel during the first 50 seconds. It means that we end the journey here, the journey will end here. I won't bother about this very one. I won't bother about S3, I won't bother about S4. If for instance they say what is going to be the total distance for the whole journey, therefore I can extend it to this point and get this. We already know how to do all these things. I've done something like this before. Just go back to other class ahead on motion, the equation of motion, how to apply it. I've had series of class on it. Just go back there and learn how to determine all this. When you are using the acceleration here, I'm assuming you want to extend it to this one. The acceleration here will be 0, but here I was using 5 because they gave me 5 there. While here I was using 8 because they also give me 8. But at this point we're using 0. But when you get to this one, you have to determine the acceleration using the formula. Remember the formula, which is V. You use this one to determine it if you want to do here. It means that here now will not be what? The final, sorry, the initial, this one will not be the initial, while the final will be 0. Therefore, I'm going to be having negative. Okay, I think I haven't done that. I have done that before. Yes, I have done it before. And look at it here. I think I have done it before. Look at it, 17. Look at it. It means that to determine the acceleration here, it's going to be negative acceleration. I will use this one as my acceleration. One will determine S4. For that, okay, that is what we were asked to look for. We're asked to stop at 50, the first 50 seconds. Now to do that, now let us see. Let us see. Please just go through so that I can train Roman figure 3 and Roman figure 4 so that I have enough space to solve. Now let me clean this one. Let me clean this part here so that I have enough space to solve. Let me clean it. Now, what is the next question? The same should, okay, for the question, the same should get the total distance. Okay, we have gotten that one now. We have gotten that one with Roman figure 3. While Roman figure 4 said we should determine the average speed. Average speed as in Roman figure, you know, average speed, yes, average speed as in Roman figure 3. It means that what is going to be the average speed there? What is going to be the average speed like Roman figure 4 now? Roman figure 4. What is going to be the average speed? The average speed, remember, we have done something of that before, that nature before. Average speed. And what is average speed? It simply means what? The total distance. Total distance over total time. As in Roman figure 3. That is okay. Now to do that now, I'm going to be hard. What is the total distance we obtain? Okay, do we move calculate? We have not calculated for the total distance. Please let us look at the total distance here. We have not done that. Please, I'm sorry for that. Here we will S1 plus what? S2. Here we will S1 plus S2. It means that S1 is what? What is S1? S1 is 3,600 plus 600 plus 5,800. Okay? Now to do this now, what is going to be? It means that 5,800 plus 3,600. Let us see what we have there. And we will have here 0. Here will be 0. Here is going to be 12. Carry 1. It's not 12, not 14. I think here will be 14. Yes. 8 plus this is going to be 14, not 12. It's going to be 14. Now carry 1. Add here, and here will be 9. Therefore, I will be having the total distance there will be 9 9,400. 9,400 meter. That is going to be the total distance for for the Roman figure 3. For the Roman figure 3. Okay, let's now look at the average speed. The average speed, as I earlier said, I said is going to be total distance all over the total time. It means that what is the total distance then? Now, for the first 50 seconds, I have 94,000. That is sorry, 9,400, not 94. 9,400 is not 94. 94,000 is 9,400. Now, saying, okay, what is the total time for the, is going to be 50, meaning my time there will be 50, 0 can be 0. Now, the next thing that I will have there, I'm going to be having 94,000. Okay, I'm going to be having what? 940 over 5. 940 over 5. That is to say 940 over 5. Now, let us see what we can do then. 5 into 9, I'll be having 1. What will be 1 left there? I'll be left with 3. No, is it 3? Is it going to be 3? 5 into 5 into, let us see the calculation. Let us see the calculation. Okay, now let us see. We said 5 into 1. 5 into 1 is 5 to 9. 5 to 9 is 1. Remember, I think we left with 4. We left with 4. If I put the 4 here, it becomes 44. Now 5 to 44, I will be having 8 remaining 4. Now that 4 put it here becomes 40. 5 to 40, I will be having 8. Therefore, my answer there is going to be, my answer there will be 8188. 188. Can use your calculator and try that. 188 meter per second. I think that is what we have. This is what we have. But what we have just done, we have just calculated it. This one is the average speed. Please don't forget, this one is the average speed. Average speed. This one we just did is what? The average speed. Average speed, you say total time, distance travel for the first 50 seconds, all over the total time, and the total time was 50, and the total distance is what? 9,400, and that is what we have just done there. When you divide it, you are going to be having 188 meter per second. I think this is all about what they asked us to solve. Thank you very much, and God bless you.